Hi, hello everyone. Welcome back to Let Us Succeed YouTube channel. I'm back with the second chapter, ninth standard second chapter, very simple and easiest chapter, that is axioms and postulates. Let us first understand what are axioms and what are postulates. Axioms, this chapter name is Euclid's geometry. Mathematician Euclid worked on these axioms and postulates. He only proposed these axioms and postulates. Let us understand what are actually axioms and postulates means. Axioms are nothing but statements. Both are statements. Postulates are true to geometry only. Those statements which are true in the perspective of geometry are called postulates, accepted as a true statements in geometry. But axioms are not like that. They are accepted as true statements across all the branches of mathematics. And after studying axioms, you will come to know that axioms are true beyond mathematics too. Let us see them one by one. First axiom, things which are equal to the same thing are equal to one another. What does this actually means? It actually means that two things. Now I am going to consider two lines, that is AB line segments AB, CD and EF. Let us assume AB is 2 centimeter and it is equal to EF, which is equal to means this should also be 2 centimeters. Now I will also assume that CD and EF are equal. That means CD should be equal to 2. Now AB is equal to EF and EF is equal to CD. It means it is also 2 centimeter, AB is 2 centimeter, EF is 2 centimeter. That means CD is also 2 centimeter. The line segment AB is equal to EF and CD is equal to EF, which means that AB and CD are equal. Both are 2 centimeters. Now let us move on to axiom 2. It states that if equals are added to equals, the wholes are equal. Let us consider two equals, AB and BC, AB and CD. No, these two AB and CD are equals and EF and GH are equals. Let us take them as 2 centimeters each. Now I will add AB to EF and GH to CD to GH. Now EF becomes 3 centimeter and GD becomes 3 centimeters. EB becomes 3 centimeters and GD becomes 3 centimeters. So when equals are added, that is AB segment line segment and CD line segment added to the equals, that is EF line segment and GH line segment, the holes are equal. The holes which are formed are the EB and GD, which are equal. Both are 3 centimeters each. Now axiom 3, if equals are subtracted from equals, the remainders are equal. Let us again consider the same example. Let us consider line segment AB and CD 2 centimeters each. If equals are subtracted from equals means I will subtract 1 centimeter. That is, I will take 1 centimeter line segment out of AB and 1 centimeter out of the line segment CD. The what remains here, again 1 centimeter line segment, and here also 1 centimeter line segment. That means the reminders are equal. That is 1 centimeters each. Now we will move on to exam 4. What does it says? It says things which coincide with one another are equal to one another. I'll again take the same example, line segments AB and CD 2 centimeters each. If I merge them, they will coincide with one another. That is, AB will coincide with CD. They will overlap each other. Means nothing is remaining extra this side or above or below, means they will coincide each other. That means both should be equal. If one is shorter than the other, they will not coincide with each other. Now the fifth axiom, the whole is greater than the part. Of course, if we consider anything, we if we take any part here, any part, it will always be shorter than the whole part. This is true, not only true for the geometry only, it is true for every branch of mathematics too, and also even beyond mathematics. If we consider any part of a thing, it will always be less than the whole thing. Next, we will move on to exam 6. What does it says? It says things which are doubles of the same things are equal to one another. Now, if I consider line segment which is 1 centimeter in length, and I'll consider CD line segment 2 centimeter and EF line segment 2 centimeter, and both the line segment CD and EF are the double of line segment AB, that is which is 1 centimeter, and these two are 2 centimeters. And of course, we can see that both are 2 centimeters each, and both are equal. Now we will move on to exam 7. Exam 7 states that things which are halves of the same things are equal to one another. If we can reverse the 6th exam, that is doubles of the same things, and here we will take halves of the same things. AB and CD both are 2 centimeters each, and I'll consider half of them, that is 1 centimeter, and half of CD means that should also be 1 centimeter only. Now 1 centimeter, and this line segment is also 1 centimeter, and this line segment is also 1 centimeter. If we subtract the same things from halves from the equals, then uh, the same things which we have taken out of the same things are equal, that is halves are equal, half of them are equal. Now we will move on to postulates, and I have already told you that axioms what we have studied from up to 7th exam, they are true to every branch of mathematics, and if we look like that, they are even true in every aspect, even in our day-to-day life too. Now we will move to postulates, and these are true only in geometry. What does postulate 1 says? It states that a straight line may be drawn from any one point to any another point. If I consider any random points on a surface, any points, now I have taken some random 5 points here, A, B, C, D, E. And our postulate states that a straight line may be drawn from any point to any another point. If I consider point A, it can be extended to any another point, maybe AB. This is a we will get a straight line. And if I consider point E, again this becomes a straight line. If we consider C, it becomes a straight line. And if I consider D, from D to E, I can draw a straight line. So like this, if I take any random points, if I start from any one point, I can end it at any another point. So a straight line can be drawn from one point to any another point. Let us move on to postulate 2. A terminated line can be produced indefinitely. Means, if I consider a line segment AB, it is a line segment, and it is terminated, means it already have endpoints A and B, but it doesn't mean that it ends here only. That means both line segment can be extended on both the sides. I can extend it on point B side or on point A side. It can be extended to any length, up to any length, infinitely any length. So a line can be produced on both sides to any length. Now we will move on to postulate 3. Or does it says a circle can be drawn with any center and any radius. We can see that from here in postulates we come across mainly geometric objects or geometric things like line segment. Particularly, it includes geometrical names here, but in exams it doesn't include any particularly any geometrical name. Here we can see that circle, it relates to circle only, means that means geometry only. A circle can be drawn with any center and any radius. If I consider point B, point A, point B, point C, point D, any point here, if I want to draw a circle with the center A, I can draw with the center A, or with the center B, or with the center C, or with center D. And also it states that of radius, circle of radius of any length. The circle can be of any radius, of length. Like this, we can draw by taking any point as a center and radius of any length, whatever, whichever we want. Fourth postulate states that all right angles are equal to one another. Of course, right angles means 90 degree only. If it is not 90 degree means we will not call it as right angle only. So that's why all angles should be equal to 90 degree if we want to call it as a right angle. Of course, it is so basic that all right angles will always be equal to 90 degree and equal to one another. 90 degree, all will be equal to 90 degree means all will be equal only. If we move on to postulate 5, it states that it looks longer but it is very simple. If a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines meet on the side. Now I will consider two straight lines, that is L and M. Our postulate states that if a straight line falling on two straight lines makes the interior angles on the same side. Now this line, let us call this line as N, which it is falling on two lines L and M and makes the interior angle. It acts as a, we call it this line N as a transverse, and these two are the lines, and this transverse line makes interior angles. The angles which I have marked are called interior angles, and here will also be interior angles. Now our postulates considers only the two angles which are less, if we consider them and add them, they should be less than two right angles. Means if we add these two angles, less than two right angles means should be less than 180 degree, and these two angles will be less than 180 degree. And if we consider, of course, these both are obtuse angles, so their sum will be of course greater than sum of the two right angles, that is will be greater than 180 degree. So we need to consider only angles of this side, and our postulate states that the two straight lines meet on that side. Now if we extend the line segments lines L and M, I'll extend this line L and I'll extend this line M. If we extend this side, those will intersect at some point. And if I extend these line segments L and M this side, and they will never meet and they will move away from each other. Hope you understood this point. Now, this is not actually the sixth postulate. This is another version of another way of stating the postulate number 5. What does it states? Two distinct intersecting lines cannot be parallel to the same line. Now, if I consider two lines which are intersecting L and M, I'll consider line segments L and M. They are intersecting, and if I consider a line which is parallel to the line L, that is line N, and which is, of course, if we observe here, line N is not parallel to line M, and it can't be parallel to line M also if I draw it in anywhere. And also if I want a line which is parallel to M, I have drawn here line P, and if it is parallel to line M, and if I want it to be parallel to line L also, if I draw anywhere else, I can't get it parallel to the line L. And if I draw here, then it will never be parallel to the line M or line L. So if the two lines are intersecting, they can't have a line which is parallel to both of them. It is nothing but postulate 5 only. Another way of stating the postulate 5, that states that lines will intersect if the interior angles on the same side are less, if sum of them should be less than sum of two right angles. In detail we will study about the interior angles, alternative angles, all these things in the next chapter. I'll make video on that too. Go and observe, and also please do subscribe my channel. Your subscriptions and likes will only motivate me to continue video making. Now this is the last point here we come across in this chapter. That is, we have only one theorem here. That is theorem 2.1. Two distinct lines cannot have more than one point in common. Now I have taken some random line segments here. Now what I will do, I will extend these line segments on both the sides, and I will extend this, and I will extend this line segment also on both the sides. Here if I extend, this will go apart from this line segment, and if I extend this will also go apart from this line segment. I have extended from this end, and they will intersect at this point. And if we look like that, it will never going to intersect or meet this line at any cost, because they are moving apart from each other, this side also and this side also. So if we consider these two line segments, they are moving apart and they have intersected at this point only, and there is only one point. And if we observe like that, there is no any other possibility of meeting at any other points here and here too, since they are moving apart. And if I consider this line segment also, if I extend from here, of course this will meet here, and if I extend here also, those two will meet at this point. And if we extend this side and this side also, they will move apart. And if I consider these two line segments too and extend this side, they will meet here, and if I extend this side, they will move apart. After intersecting also, if I extend this way and if I extend this line this way, they will move apart from each other. So they can never intersect at any other point other than these points. So two distinct lines can't have more than one point in common. They can intersect at only one point. And this is all about the chapter. This chapter is very simple and easiest. If you want me to solve exercise questions, even exercise questions in this chapter are very simple and very easy. And if you want me to aid you, I will aid you in the and try to making video about those exercises. Please comment if you need that. Thank you for watching my video, and don't forget to subscribe.